Column right here. Here this question is asking, write a code fragment which sets PA4 high, delays the MPU exactly half a second with a 104.8576 Hz external oscillator, and sets PA4 low, delays another half a second, and repeats using only instruction delays. Use subroutines. Okay. So here they have mentioned that it delays exactly half a second, and also here provided 104.8576 Hz external oscillator, that is basically external. So here external is provided. That is that is provided 104.8576. Okay, and if you divide this one by 4, you will get an internal clock. So internal clock is external divided by 4, and that is 1 over 104.8576 Hertz. .8576 Hertz divided by 4, and that is 26,226,2144. Okay, that is internal cycle, internal clock, and that is basically this many cycles per second. So this is 26,000, actually 262,144 cycles per second, and it's also here also mentioned that it delays the MPU exactly half a second. So we have to look for half seconds. So this is going to be again half of this. Half of the 262,144 is 131,072, and this is for cycles per half second. Okay, and based on using this information, we are gonna achieve our results, and this is the number of cycles we have to achieve. So in order to do that, we are gonna go ahead and create the program. So the program is this is 68HC11, and then here we do the start first, and also here we do the PA4 high and PA4 low. For the PA4 high, we load the value that is 16. You can either do it in binary or hexadecimal. Let's look at the difference. So here first you load the value, load to accumulator a value. So I put a number sign to mention that's a value, and then a percentage sign, this represents the binary, and then 0001 0000. This is 16 in binary. Now you can also either put this one as well. If you put a dollar sign, that's a hexadecimal, and you can load 16 like that. Okay, you can do either of them. You can either do this or that. So once you have loading, then store accumulator A into port A, and then ISR delay. Okay, this is for PA4 high. Now for the PA4 low, it's instead of 16 we put a 0 for it. So load accumulator A with 0. I'm mentioning 8 bits here. In hexadecimal I put a 2 digit because each digit represents 4 bits. So that's why we only need 2 digits for it, but in binary we need 8 digits to represent the 8 bits. Okay, and then store accumulator A into pod A, and we using a subroutine JSR, and that is delay, and then BRA branch to new error, that's start. Okay, and the next upcoming program continues down. I don't have space, so I'm going to go ahead and continue my next page. So it's like it's go up to top to bottom, but I go to the next page and continue the rest of them. So now we are going to achieve the delay. So to achieve the delay, what you do, just put a name delay, and here we are going to load X with how many delay we want to achieve. Here, as we calculated here, this is the number of delay we want to achieve. Okay, so in order to get that, I have to decide the number of number of LTX it has to be given here. So I give I leave it for now, and then 3 cycles to load X, load a value into X. It needs 3 cycles. Okay, so that's why I put a 3 cycles here. That's just a mention, that's not represent the code. If you put a semicolon, that is just a comment. Okay, then I'm creating another name called delay loop. Here we are going to run a loop to achieve this many number of cycles. So to achieve this cycle, we are going to use DEX, that is decrement of X. Okay, and that takes 3 cycles. And then you can either use NOP, BNE, or anything. Like BNE is required because we want to run this loop again and again until it becomes 0. So I put a BNE here, and that one takes 3 cycles. And here in the BNE we mention once it if it doesn't reach 0, a branch not equal to 0, it has to go to this one. Let's name this one delay loop. Okay, I put the same name here. So you can either name anything you want, like you can put a loop 0, and you have to make sure that you put the same name here as well. That's the only thing, but just to be clear, delay loop, you put the same name here. So this loop is gonna repeat again and again until it achieves that many number of cycles that is required. Okay, now from based on this, so this one, when you load, it takes 3 cycles. It's only going to happen once, then it's going to enter the loop, and it's going to run again and again and again until the X value reaches to 0. So if you like, let's say right now 130,072, and this gonna repeat, these two are gonna repeat again and again and again. So 6 times how much? Okay, let me use a calculator. Like I take the 3 out of it because 3 is already gone. So if I take 3 out of it, then that is like 130,069. Okay, 131,069, and I'm trying to divide this by 6 to see how many times I need to run, And if it becomes a whole number, no problem, but if it's a fractional, then we have to do something. So that gives a fractional number, so that's not gonna work very well. Okay, so I had to add some extra delays. And also, you know, after it becomes 0, it's gonna also has to end, and for that one we need to use RTS, and that's gonna take 5 cycles, so I had to decrement that one as well. Okay, so 3 plus 5, 8 is gone. So if you subtract 8 from this, that is 64 right now, 131,064. 131,064, and if I divide this one by 6, I'm still getting fractional. Wait a minute. 131,064. Okay, if I let me put this number again, 131,072, and these 3 will be gone, and 3 plus 5, 8. Okay, 8 will be gone, so minus 8 right here, and that is 131,064, and then you divide this by 6 to see how many decrement has to be done. So I divide this one by 6 right here, and that is 21,844. So if I put 21,844 right here, let's see if the math work out very well. Actually, not here, loading value. 21,844, and to make sure this is a decimal value, we just put a number sign. If you don't put a number sign, it's going to represent the address, so that's going to be a different story. So to make sure to refer this is a decimal number, we put a number sign right here. Okay, so we load x with this value, and then we decrement x, and it's gonna reach 0 and then exit the loop, and it goes here. So 5 plus 3, 5 plus 3, then plus 21,844 times 3 plus 3 should give us this number back. If you don't get it, we have to do some adjustment. Let me put it in the calculator and make sure it's exactly giving that. 5 plus 3 plus 21,844 bracket 3 plus 3. Okay, that is giving me 130,007. So that basically works good. We don't need anything extra. So let's actually double check is there anything else has to be done. Write a code fragment which sets PA4 high, delays the MPU exactly half a second with this external number, and sets PA4 low, delays another half a second, and repeats using only instruction delays. Use subroutines. Okay, we have done everything, and that's basically it. That's it for this video. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.